In this episode, we're going to be talking about solving systems of linear inequalities. And so I think it's appropriate that we start out by just reviewing how do we graph an inequality. So there are going to be two main ways that we can use to graph the equation of a line. One way is going to be using your x and y intercepts. All right, so we're going to take a look at this inequality right here, negative 3x plus 4y is greater than 12. And we're going to figure out what the x and y intercepts are. Now, one of the things to remember is that any point that is on the x-axis has a y value of 0. Well, if the y value is 0, we can substitute this 0 in for y, and then 4 times 0, that takes this term out because this term will be 0. Now you're left with negative 3x and it's greater than 12, which means your x value is going to be negative 4. So that is going to be your x-intercept. For a y-intercept, your x value is always 0. So that means if we put 0 in for the x, this term will go away because it'll be 0. That will leave you with 4y is greater than 12, which means y would be 3. So we now have 0, 3 and negative 4, 0. All we need to do is graph those 2 points. So let's go ahead and do that. First thing we'll do is come over here, plot negative 4, 0, and then 0, 3. And when graphing lines, all you need is 2 points, and that's what we have here. Now, the other thing to take into consideration is going to be this inequality. If you have just a greater than or just a less than, what you are going to have is a dashed line. If you have greater than or equal to or less than or equal to, you will have a solid line. Now, in this particular situation, our graph will be dashed. So we can sketch this dashed line in here. When doing your graphing, actually use a straight edge. The next thing we need to look at is the shading. Are we going to be shading on the bottom side or the top side of our graph? And so with this, what we want to do is pick a test point. Pick a point that is on either side of your graph, and we'll test it in the inequality. Now, the easiest point to use, if possible, is going to be 0, 0. So if I plug 0 in for x and 0 in for y, what that gives me then is 0 is greater than 12. Well, that is a false statement. What that means for us is that we will not shade the side 0, 0 is on because that gives us a false statement. Therefore, we will shade the other side of our graph. And this is your solution area. Now, the solution area means that every point that is in this area, if you plugged in the x and y values into this inequality, it will give you a true statement that this side would be greater than 12. Every point in this region will give you that. All right, let's take a look at the second main way that we can graph our lines. This is going to be using from Algebra 1 your y equals mx plus b, your slope-intercept form. And so if we use our previous equation of negative 3x plus 4y is greater than 12, what we need to do is solve for y. So we would add the 3x over to the other side, giving you 3x plus 12, and then you would divide by 4, giving us 3/4 x plus 3. So the 3 right here represents your y-intercept, and 3/4 represents your slope. So you'd start out by graphing your y-intercept of positive 3. And then from there you would rise 3, which means go up 3, and to the right 4. Now just like before, if it is just a greater than, it is a dashed line. And then the inequality, as far as what side we're going to be shading, this is kind of intuitive here. Look at your inequality. We're looking at y values that are greater than this. Well, this part right here is your line. So y values greater than the line would mean y values that are above that line. That tells us that we need to shade everything that is above this line. And you'll notice that that is the same graph as we had over here. Those are just two separate methods that you can use for graphing lines, graphing inequalities, and it just depends upon the situation. One might be easier than the other. It's good to know both methods. All right, so let's take a look at this system of inequalities. Now, the only difference between a system and just a single inequality is your solution region. Your solution area is going to be where the shaded areas overlap from the two inequalities. All right, so graphing the first one, if we use the method of intercepts for the first equation, or inequality rather, if we put 0 in for the x, that would give us 4y less than or equal to 12, which means y is 3. And then put 0 in for the y value, which means you have 3x, negative 3x less than or equal to 12, so y is, x is negative 4 rather. All right, so that gives us these points, 0, 3, negative 4, 0. Those are the same from the previous problem. This time, however, you have less than or equal to, which means this is a solid line. And we are not going to shade yet because we need to graph the other line as well. Now, let's think about the shading for a second, though. If we pick a test point of 0, 0 on this one and substitute it into this, you would end up with 0 minus 0 is less than 12. Well, that comes down to is 0 is less than 12. That is, or less than or equal to. That is a true statement, which means we will be shading on the side that 0, 0 is on. So we will be shading below this line. All right, let's do the second inequality. So if we again use intercepts, plugging 0 in for x, you get 2y greater than or equal to 2, so y is 1. And then putting 0 in for the y value, takes this term out, leaves you with x is less than or equal to, greater than or equal to 2. All right, so then plotting your points, you're going to have 0, 1 and 2, 0. This also will be a solid line. And if we use a test point of 0, 0, we'll end up with 0 is greater than or equal to 2. That is a false statement, so we will not shade the side 0, 0 is on. The shading for this line would be above the line. The shading for this line is below the line. So the overlapping shaded region is going to be this region right here. That is the solution region, so that is the only part that we will be shading. All right, let's look at the next one. On this one, let's graph these using slope-intercept. It's really kind of nice because the first inequality, all you have to do is add 7 to the other side, giving you 4x plus 7. We can graph the y-intercept of 7. And we can graph the slope of 4, which is going up 4 and to the right 1. But that goes off my graph, so I'm going to use going down 4 and left 1 will give me the same line. It has just a less than, which means this is going to be a dashed line. And then the shading on this says that y is less than this line, which means we would be shading below the line. So if you put your finger on the line, y is less than, so you would go down, which means we are shading this side of the line. Okay. All right, so the next inequality, we can solve for y by simply dividing by 5. That will give us 3/5 x minus 4. So negative 4 is your y-intercept. We'll rise 3 and run 5, so up 3 and over 5. This also is a dashed line because it does not have an or equal to on it. And this is less than as well, which means we will shade below this line. So we're looking at shading below this line and below this line. So the overlapping shaded region is going to be located down here. All right, so the next one is going to be kind of a mixture, I guess. We're going to take the first inequality and let's just solve for y. So y would be greater than or equal to 1/2 x plus 4. We get that by dividing everything by 2. Also on inequalities, remember if you divide by a negative number, you would end up switching the inequalities around. Okay. All right, so on this one, 4 is your y-intercept. Up 1 and over 2 for your slope. Solid line because it has the or equal to. And shading is greater than or equal to, so we would shade above this line. We'll just keep that in mind as we graph the next one. All right, so the next one, we could use the intercepts. Let's use the intercepts here. We could graph it either way, it doesn't really matter. Well, let's go ahead and use y is less than negative 4x minus 3. Let's just use your slope-intercept form. So negative 3 is your y-intercept. and you have a slope of -4, which means down 4 and right 1. Also up 4 and left 1 would get it there as well. This does not have an or equal to, which means this is going to be a dashed line. All right, this has less than, which means we will shade below this line. So everything below this line, but above this line. So that would put us in this region right here. This region is less than this line, but greater than this line. So the overlapping shaded region is this one right here. All right, next one. First inequality, let's subtract x, gives us -x minus 2, y-intercept of -2, and the slope is down 1 over 1. Solid line because it has an or equal to. And we would shade below that line because its y is less than or equal to. So keep in mind that we're going to be shading this region down here. All right, so the next one, if we solve for y, this will become 3y less than 2x minus 1. And then dividing by 3 will give us 2/3 x minus 1/3. So this is a little bit harder to graph, I guess, because of the fraction for your y-intercept. You just have to be approximate with this. All right, so -1/3 is approximately right here. From there, we're going to go up 2 units, so up 1 and then up 2, and then we'll go over 1, 2, 3. That'll put us right here. All right, this is less than only, so we will make a dashed line. And less than, so we will be shading below this line, and the other one was less than this line, so below this one also would put us in this region right here. So that is our overlapping shaded areas, this right here. All right, this system is going to have a system with 3 inequalities. And so if we take the first one and let's graph using y equals mx plus b. So solving for y will give us 3y greater than or equal to -x minus 17. And then we have to divide by 3. So that's going to give us -1/3 x minus 17/3. Now keep in mind that -17/3 is the same thing as -5 and 2/3. So we'll plot the y-intercept, 1, 2, 3, 4, 5, and 2/3. -5 and 2/3 will be about right here. From there, you're going to go down 1 and over 3, which will be about right here. All right, so we've got our 2 points, and this will be a solid line because it's greater than or equal to. So graph with a solid line here. And we're shading above this line because it has the greater than. So shading everything up here would be shaded for just this inequality. Now the next inequality is x is greater than -5. Well, x equals -5 is a vertical line at -5. So that's what we're going to draw. 1, 2, 3, 4, 5. It is going to be a dashed line. And on this one, there's no above or below, so greater than is going to mean to the right. So we would be shading everything to the right of -5. So right now, the overlapping area is everything above this line and everything to the right of this line, so that would be this region right here. All right, so now we have one more inequality on this, and it's already in the slope-intercept form, so let's go ahead and graph this. Slope, see y-intercept of 2, and then up 1 and over 4 for your slope. It's going to be a dashed line. And this inequality says everything that is less than that line. So now everything above this line, to the right of this line, and below this line would be this region right in here. So that's what we will be shading. Now keep in mind also that when you have a graph of a solid line, what that means is that points that are on that line are also solutions to this inequality. So points that are on this line are valid solutions. Points on a dashed line are not valid solutions to your inequality. Okay, so there's a couple of things to remember. Now this system had 3 inequalities. We could also have a system with 4, 5, 6, any number of inequalities. And the solution is just the overlapping shaded region from all of the inequalities.